What if the key to living forever actually lies deep within your body's cells? At the very ends of your chromosomes lies a clue to unlocking one of humanity's oldest dreams: stopping aging itself. Your cells are built to replicate. During early life, cell division enables the body to grow from a single fertilized cell into a fully formed organism with trillions of cells. Cell division is the engine that drives growth, maintenance, and repair in the body. But each division brings the body closer to its expiration date. Aging is in part the body's diminishing capacity for cell division. Inside your cell's nucleus, at the very ends of your chromosomes, exist these simple strands of DNA. And recent research is revealing how important these things are. Microscopic caps called telomeres are the ticking clocks of your cells, counting down the moments until they have reached their limit for dividing. Choices you make every day, what you eat, how you sleep, and even how you handle stress could be speeding up or slowing down that clock. Each time a cell divides, the telomeres at the ends of the chromosomes shorten slightly. Over time, telomeres become critically short, which prevents the cell from dividing further. This is somewhat oversimplified, I'll admit. All aging really is. This process contributes to cellular aging, or senescence. And so aging occurs when too many cells lose their ability to divide. You might imagine then that evolutionarily, a cell with extremely long telomeres, capable of replicating longer and longer, would be selected for, so that we could live for hundreds and if not dozens of years. There are of course much longer living vertebrates than us. The Greenland shark, for example, is expected to be able to live for over 400 years, so why not us as well? After all, it's in our body's best interest to last as long as possible. One idea proposed is that this shortening of telomeres is an evolutionary mechanism to limit the number of times a cell can divide, to act as a safeguard against cancer, as cancer cells divide uncontrollably. I first heard of this idea from evolutionary biologist Dr. Weinstein, as his contribution to the evolutionary understanding of telomeres lies in his framing of telomeres as a solution to an evolutionary trade-off. This delicate trade-off is known as the telomere paradox. Weinstein suggests that the length of telomeres in different species reflects their evolutionary strategies based on different environmental pressures.
You have a genome that's complex. It's full of genes, but there aren't enough genes to have a gene for every trait that you have. In fact, they're a tiny fraction of the number of genes you would need to cover all of the various characteristics you have. So genes always do multiple things. And in the case when a gene does something that's very good for you when you're young, at some cost when you're old, selection tends to favor it because you may not live long enough to suffer the cost. So selection sees early life much more clearly than it sees late life, and it prefers things that help you early, even at a cost of harming you late.
Short-lived species like mice tend to have long telomeres and less robust tumor suppression, because their lives are often cut short by external factors like predation. Investing heavily in anti-cancer mechanisms isn't evolutionary advantageous to them. Longer-lived species like humans or elephants tend to have shorter telomeres and stronger tumor suppression, aligning with their lifespans and slower reproduction. However, this comes at a cost of age-related diseases and senescence. So how can we use this to combat reduced longevity? Cell damage accumulates over time due to a variety of factors, including oxidative stress, inflammation, and environmental toxins. In other words, reducing cell damage isn't just about slowing down the clock on telomeres, it's about giving our cells the best chance we can to repair themselves and function properly for as long as possible.
I'm just kidding. Come on in. I've been waiting for you. Welcome.
Bryan Johnson is a tech entrepreneur and biohacker. He gained recognition as the founder of Braintree, a payment solutions company bought by PayPal in 2013 for $800 million. But that background information isn't particularly important as of now. I just want to say that whatever we're about to go over, he can definitely afford. Bryan has now turned his ire to advancing the scientific approach to slowing aging and enhancing lifespan. He's spending millions annually on his personal health regimen. Bryan's highly disciplined routine includes many practices to help preserve telomeres, and claims his pace of aging is 0.76, meaning that for every 365 days, he ages only 277. People often have a very strong reaction to Bryan's work and personal life, positive or negative, and I get it. A lot of the things that come out of his mouth can be on the creepy side.
I'd be more than willing to offer you my plasma here at my house, and we're hanging out, we're having fun, and you feel naughty, and you are coming here. I mean, let's just look. What could you do to be naughty?
But I don't see how that is particularly relevant to the results that he gets.
I'm excited. This really makes me happy, so let's go.
And while Bryan's routine is inaccessible to most, it does shed light on the science behind longevity and offers lessons anyone can apply. The choices we make every day, from diet and exercise to stress and sleep, directly impact our telomere length and ultimately how long we will live. It's probably not new information to most what a healthy life looks like. Bryan's been quite open about what he does each day to achieve these results. He meticulously avoids processed foods and eats entirely for cellular health. Strength training, cardio, and rest days help keep his body in balance. 8 hours of deep restorative sleep, tracked with obsessive precision. Meditation and mindfulness lower cortisol, a major telomere enemy. Hormone optimization and cutting-edge tech fine-tune his biology. All of this is in an effort to reduce cell damage, and he appears to be getting these results by treating his body entirely on the cellular level. So, should we? In theory, a solution to the trade-off between limiting cancer risk by shortening telomeres and allowing for proper tissue repair by maintaining them would involve a way to balance cell division and repair without letting cells divide endlessly or age too quickly. So while the fountain of youth may be still as ever just out of reach, science is bringing us closer than ever. And by understanding the role of telomeres, we're uncovering the secrets to aging, one cell at a time. At its core, the telomere paradox is about balance. Eat foods that nourish your cells, move in ways that strengthen your body, and sleep like your life depends on it. Because it does. And most importantly, manage your stress. Because your daily problems just aren't worth the tears.
Hello, Editing Joel here. I just want to say thank you to making it to the end of the video. Thank you to everyone who subscribed as well from last time. I think I got 700 or so of you, which is absolutely mental. I can't thank you enough. So if you do have any ideas for future videos, leave them in the comments down below. Like, share, subscribe, etc. Bye.